Hi, my name is Srinivas Nasaman and I'm an associate professor at the Robotics Institute in Carnegie Mellon University. And I'm going to be describing a joint project that we are doing in collaboration with Intel. And this is a smart headlight that can allow you to see through rain and snow. So imagine you're driving at night and it's pouring pretty hard. You see all these rain streaks coming at you, the bright flickering streaks. And so a headlight essentially lights up all of these streaks in addition to the road, and it makes it very stressful to drive at night. So what we are doing is we are being a little bit smart about it, and we are going to figure out how to stream light in between the raindrops or snowflakes so that you don't see the weather in front of you. Okay, so it sounds like a very simple idea, but it's a very technically challenging problem, engineering challenging problem, because we had to first detect where the raindrops are, where the snowflakes are, and very quickly predict where they're going to be in the next millisecond and turn off the light trace at that location. Okay, this gives you a feeling that you're not seeing anything in front of you. Okay, and that hopefully can make it less stressful to drive in rain and snow. Okay, so this is a setup that we have here, and that's Robert, my postdoc, who's working on this. He's the main guy making this possible. And so we have here behind a camera and a projection system that's acting as our smart headlight. So the camera is very quickly going to be imaging where the drops are, where the snowflakes are, and then it's going to pass it on to the computer, which is going to predict where the snowflakes are going to be or the raindrops are going to be in the next few milliseconds. And that's going to be passed on to a projector that then sends out light patterns that are binary, black or white. Black wherever we don't want to hit the raindrop, and white wherever there's no raindrop. Okay? So here's our very sophisticated raindrop generator. We have a bunch of valves here that are controlled, and water is fed through this tank. And when the valves open and shut, you have drops coming out. So now you see the drops are coming out. It's about 2 drops per second, and there are about 16 valves here. You can always do many more, but we just put in 16 for now. And so this is about 32 drops per second. So if you collect this over an hour, given the radius of the drops, it's about 90 millimeters per hour. So it's a very strong rainfall, but it's in a small region for now. Okay? So there's no restriction as to how much the field of view needs to be, but for this demo, we are just keeping it into a small field of view. And so if the rain, if you have a standard headlight that is just lighting up all the way through, you see a lot of these bright flickering streaks. Okay? And now Robert here is going to turn on the smart headlight. Give a few seconds. Now you don't see the rain at all, right? So what it's doing is it's trying to figure out where the drops are, and very quickly, before you even notice it, it's streaming light in between the rain and the snow. In this case, just the rain, okay? So just as a comparison, Robert will now toggle. That's the standard headlight, okay? That lights up all the time, and that makes it stressful to drive. We're showing a comparison between what happens if you light up the drops and what happens if you miss them. That means you're not seeing those drops as brightly as before. And so the idea is if you make this system faster and faster, you can now put it on a car and travel at, let's say, 60 miles per hour in a thunderstorm and reduce the visibility of rain by about 70 to 80%. Okay? To get there, we need to be about 400 hertz, so we need to react at about 400 hertz. Right now the demonstration is going at 120 hertz. So we think this is feasible enough, and we will be able to move towards that 400 hertz within a few years. And then we can compactify this system, we can integrate the imaging, the illumination, and the processing within one device and put it in a car.